Today we will talk about an overview of data mining models. Now let us define data mining. What's data mining? Data mining is actually the part of more complete process called knowledge discovery in database. This process derives the information pattern needed by the data mining. But what the data mining does? Data mining does use of algorithms to extract the useful information and patterns. These patterns and information originally derived by the KDD. Now, what is KDD? It's a process of 5 stages. A process of finding useful information and pattern in data. Let us know it more in details. The first stage is selection to obtain data from various sources. Then we proceed to the next stage to cleanse this data through pre-processing to remove undesirable items. And then we transform this data into a common format to be used by the data mining techniques to obtain the desired result. But we don't understand this result. We need to make interpretation and evaluation to present it to the end users in more meaningful form in order to make the correct decision. The whole process now here is treated. Selection, pre-processing. Selection use the initial data and convert it into target data. The initial data comes from various sources, and now we extract this data from various sources to obtain the target data, which is cleansed by pre-processing to remove undesirable elements. And then through transformation, we transfer it into the required format to be used by data mining. For instance, we use to convert it into rule base. We convert it into common scales like that. And now data mining use this transformed data to obtain the result, which could be a model or numerical values. Then we don't know what these models means or what these results mean. We need to interpret it into useful knowledge to be used by the end user. Now, the categorization of data mining models. Like any models, we need to categorize data mining techniques. There are 2 main techniques, the predictive and descriptive. The predictive predicts the new data value by using known answers from different data values. This means that if we make forecasts, for instance, using time series analysis data, we use the past historical data through some averaging process to obtain the estimated values of the other of new estimated values. And whereas in contrast, descriptive don't use any known results, but works by identifying the patterns and the relationship inside the data itself. Like clustering, we cluster the data into disjoint groups where each cluster has similar characteristics. Also, association rules find the rules that govern the relationship between different fields of the dataset. Sequence discovery, identify sequence pattern in the data that's related usually to the time. So the predictive models make prediction about the values of the data through known results. This is what characterizes the predictor, the use of known results. But the descriptive models identify patterns, relationships, and don't use any known results. And mostly called descriptive models called unsupervised, but predictive usually called supervised. Now let us navigate through the classes or categories of this approach, starting by classification, which conduct mapping of this data into predefined. I want to make classes, and through this class I can classify items thereafter. And from this approach is supervised learning, pattern recognition, and prediction. We predict like making forecasting. Supervised learning, we classify new data by using past historical data or existing data. And pattern recognition is to recognize patterns in images or in numerical data through some algorithms. This will be explained later in this course. Regression is used to map data items into a real value prediction variable. We have to make equation. This is maybe linear regression or nonlinear regression between the input data items and the variables. So through this equation found, we can estimate or compute the real value prediction variable. This is a regression. Next, clustering. Clustering make clusters, make groups, joint groups. Each group has similar characteristics. Some of the examples of this clustering are unsupervised learning, segmentation, and partitioning. And segmentation differs from partitioning. Is the segmentation is we make disjoint groups, but partitioning, some of these groups may have common roots. Summarization simplifies the data. It creates subsets of the data in subsets and with more simple descriptions, including, for instance, characterization. We find some characteristics, summarize the properties of this data. Generalization, we could summarize this data into more general norms or rules. In link analysis, we uncover relationships. We found the relationships in this data through some techniques, including affinity analysis, association rules, where this is very commonly used in practice to find rules govern the relationship between different fields of the data set. And in sequential analysis determines sequential patterns, usually in terms of time between some events. Now let us take the k-nearest neighbor as example classification algorithm to explain how this algorithm works. First of all, we want this algorithm belongs to classifications techniques and based on distance measures. This means that in nearest neighbor, we estimate the distance of each element from some closest neighbors. How to use this or make this useful? In order to classify any item, new items, its distance is calculated to each item in the training set. Then we, through specified number called k refer to k nearest neighbor. Only the k closest entries in this are considered. Then we look at this k closest entries we found. Then which class to classify new items? We look at these numbers or these entries, k closest numbers or k neighbors, and we assign the new item to the class with the most k closest entries, which has the greatest entries in this set. Then we classify this way. It is illustrated more in using figures. Here we have the data set. We have new item t. Then we calculate the distance from each elements, and then we search the closest elements. Here, this and this and this. Then we find the class of each element, and for each class we calculate the number of neighbors, and we classify T according to the class which has the most number of neighbors in this neighborhood. Important parameters is the k nearest neighbors. It could be specified 3 or 4 and have some impact on the performance of this algorithm. K is the number of neighbors, or number of close elements, and we classify T in the class with most of these are members. Now let us more formally view the algorithm of k nearest neighbor. We have inputs, 3 inputs training data, and Also, the number of neighbors specified, k, could be 2, 3, 4, 5, and it impacts the performance of this algorithm, because this is more deep issue. We defer it later on in the course. Now, T is the input tuple to classify. The output is the C. We want to classify T to which class C is the output, class to which T is assigned, classified. The algorithm starts with empty set of neighbors. We want to find these neighbors in order to judge which class to assign T. How to find this N? We through applying this loop. For each D, any tuple belongs to T, we check through this branch if the number of elements in this N less than or equal K, then we add D to this set of neighbors. If not, this means that if N number of elements greater than the specified number of neighbors, then we find any tuple belongs to this set if there exists this tuple belongs to such that the similarity of T to U, the U to the elements tuple we wanted to classify, less than or equal similarity of T to D. Here the similarity refers to the distance. If the distance is close, then the similarity is large. This means that this is the distance is close, more close. Then we remove these elements U from this set and put instead D. Then after obtaining, we end the loop to obtain the set of neighbors through this algorithm, and then we assign the T to the class which has the most U in the set, most number belonging to this class. Now, a very good reference to know more about the predictive and descriptive data mining techniques is through this reference box, which contains plenty of examples and explanation and very simple description, is the Margaret Dunham Data Mining Introductory and Advanced Topics. Thank you very much.